all of you can imagine, and those of you who can't imagine, you probably live this day to day. One of the challenges that we have is to prove that to our customers that vanadium flow batteries actually deliver the kind of reliability and performance and lifetime that we all talk about as being one of the hallmarks of this technology. And so what we've been doing is putting some work into trying to figure out exactly what that means and exactly how we can both convey that to our customers and prove using real world data that we are achieving those benchmarks. We've broken those out into a couple of different dimensions around: are we meeting the specifications for the batteries? Are they able to operate in parallel with one another on a particular site? And then ultimately, are we delivering the flexibility and durability that are needed from each one of these applications? So with that as voiceover, let me hand it over to Invinity's head of sales engineering, John Senf, who can walk you through the detail behind this work that is ongoing. John, over to you.
Thank you, Matt, and thank you, John, for having us. So, confirming you can see the presentation fine?
All good. Yep.
Good stuff. We'll crack on then. So, and also please excuse any throat clearing. I'm coming off the bat a bit of a sore throat at the moment, but I'll try and keep the coughing to a minimum. So, as Matt mentioned, we've gone about trying to prove to ourselves and to customers and to the outside world the performance and reliability of our system, and we do that over these several metrics that Matt touched upon. Really, this is are we meeting the specification that we're putting out on our data sheets and that we're going to be warranting for our customers? So just the raw performance of the battery itself. Then looking at the coordination of the batteries, are they working together to deliver that larger site-wide and project battery deliverables rather than just on a single module scale? Are we delivering flexibility to the customers in their use cases, whether that's variable dispatch on a single site or future-proofing their batteries for operations and markets that they'll be seeing going forwards? And finally, how are we proving durability and lifetime expectations of our batteries that we're selling to these customers? And again, we're warranting that lifetime. We do all this through a huge amount of data that we're gathering from the fleet that we have installed in the world at the moment. We have designed, built, and deployed the world's largest fleet of flow batteries, and we get a tremendous amount of data back from our data platforms that we're able to look into to start demonstrating these. So the key way we went about this was by engaging with DNV. They are a global leader in risk management, and we engaged them to perform a bankability study on our current product, which is the VS3. So they looked at the whole company and the product from front to back, but we'll talk about a few key areas that they looked at here. They looked at power and energy on charge and discharge, system and battery level response time, efficiency, and our comms interfaces. And across the board, DNV reported that the VS3 performance either met or exceeded the figures we put forward on our data sheet here. And this to me is really important because this highlights that the data we're putting out to customers and on our sheets is not idealized lab-based data that is possible. This is real achievable data that the customer will see from the batteries installed in their sites around the world. So that was a really strong thing for DNV to be validating and proving in this report. They also noted a couple of key additions, which was our performance was consistent amongst cycles, and also we were able to perform multiple back-to-back cycles without any degradation in that performance. Continuing on the specifications metric here, the next one they validated for us was the response time. So in order to participate in a lot of the grid or frequency markets that exist in the UK and worldwide, the battery needs to have a very high response time. Apologies for any flash ups there. The battery needs to have a high response time, or rather a low response time, a quick response time to the requests it gets in from the wider site. So what we were able to show with a battery, and this was not a lab battery as such, this was a production level battery that we set outside our facility in Scotland, was that we could get a full power swing from full charge to full discharge in less than 150 milliseconds. And that was including the PCS that was on site there. The next step we were able to do was scale that up to a full-size system. So this was a 2 megawatt site operational, drawing in data again that we were capturing and providing to the DNV, or to DNV, that the typical speed of response, including the PCS for a 2 megawatt site, was still a quarter of a second, 250 milliseconds. And you can see in the box on the bottom left there, the summary that DNV put forward was that the batteries, Infinity's batteries, are responding in an equal time to lithium batteries, and therefore are able to participate in almost any service that is needed in the UK. And you can see a couple of graphs on the right here. This is our sort of lab view, but the single battery we had in our factory. And then this is the site-wide response that we were doing for our 2 megawatt system. The next step of the specification was really about the multi-cycle operation and that resiliency of being able to do back-to-back cycles. So on the right there, we have a couple of graphs. The top one is just showing 3 back-to-back cycles at nominal power of the battery, going full 0 to 100 charge and discharge with 0 rest period in between, running straight back-to-back into those. And DNV noted that there is no risk of thermal runaway or fire with the Invinity VFBs, and there's no cycle we impose on those batteries either. The ambient temperature, it was summer at the time, was between 19 and 25 degrees Celsius. And you can see in the bottom right, that green line, sort of that sawtooth waveform we have going along there, is the electrolyte temperature within those batteries, the average electrolyte temperature of the modules. And you can see there, as said, with that sort of sawtooth up and down, the temperature drops as we charge the system and then increases as we discharge the system, but it remains stable across those 3 cycles, basically demonstrating that you don't need a rest period, you don't need to take any time between those cycles, and you can just run it fairly continuously without risk there. And for each of these 3 cycles, the system was dispatching a greater than its nameplate capacity of 230 kilowatt hours for the module. The second criteria that we talked about at the start is coordination. It's all great to have a single battery operating by itself, but how do you bring all of those batteries together to make the system respond from a site level? Now, it's even worth noting in the slide before that one VS3 production unit that we had is still comprised of 6 individual modules. So there's a level of control and coordination that's happening there as well. But we took this a step further and referencing some data from our site we have operating Energy Superhub Oxford in England, one cluster of this site, which is the data that's represented on screen, one of 3 clusters, is 54 individual battery modules operating together to respond to site needs over the course of, this is about a week's worth of data that we've pulled out there. So you can see every one of those modules is operating very tightly to each other, responding to the needs of the site, responding to the needs of the system. And after a week are still in line, still, they've not begun to drift apart, and those batteries are not connected fluid in any way. It's all just an electrical connection for those batteries. So able to keep all of those batteries operating together, providing that stable power whilst maintaining coordination amongst them all. That third criteria is really just around flexibility. So we talked about the multiple use cases that a battery might be called on to do. That's always not evident. That's not always evident at that first inception of a site. Very often projects are specified on single sort of full cycle basis or single use case. But in reality, once you get that battery on site, there are multiple different dispatch profiles that can be combined to either increase revenue or even just serve the needs of that site. And what we're able to demonstrate with that sort of coordinated and stochastic response we're able to give there is that we have unprecedented flexibility in meeting these very dispatch requirements. So whether you're doing sort of intraday trading or whether you're doing frequency response in your market, there's no change, and the battery has no preference really as to how it's operated. It can respond to any of those requests and change at a moment's notice. And that gives kind of that unparalleled flexibility and also future proofing to any changes that might come in revenues that either governments or the market might offer to that battery. And this was done using the Energy Superhub Oxford case study, which is that 2 megawatt, 5 megawatt hour flow battery, the largest flow battery in the UK and the world's largest lithium flow hybrid. It's been in operation since the end of 2021, and we've been getting great data since then. So looking at that site specifically, in the bottom left here, you see a year-to-date snapshot of that data. It's obviously very compressed there, so we're not looking to glean a lot from that particular, except showing that the battery has been operating consistently all throughout this year, meeting a variable need of the site really as the needs of the system change. We zoom in, then that little gray section at the end there exploded out into October here, and you can see clearly that the battery is operating in both multi-hour energy trading, but also sub-second ancillary services, including dynamic containment and that firm frequency regulation. So really, we don't need warning, or we don't need, prepped by the customer as to how this battery is going to be used. We hand it over to them. It interfaces with our battery, our system controller, and we take that site controller input and just respond to the needs, to the second or to the half second as is needed for that site. So the battery has been operating in multiple different use cases consistently now for a period of years. And that fourth criteria we talk about is durability. So again, it's great to have a battery that works, that can coordinate and is flexible, but if you don't have the lifetime on that product, then it doesn't really show much. So we engaged with Nextracker, who performed an accelerated lifetime test in California on one of our batteries, outside in the sun for a very long time. They performed an accelerated 30-year lifetime test on the battery. They put together a standard sort of solar plus storage duty cycle, compressed that really, really heavily, and just ran the battery solid for an extended period of time, accelerating that lifetime analysis up to 30 years. And the results of that were fantastic, really. It was the projected capacity of the battery after 30 years was still over 95% of that original capacity, kind of reinforcing what we all know, really, about vanadium flow batteries, is that lack of degradation as you cycle them. They can be used day in, day out, as hard as you want, and you will see no real performance-based degradation on that battery. And that was really great to have this reinforced. This was also released by DNV in a separate report earlier. So they took this data, validated it, and put it out into the world as a sort of stamped and approved study on the battery. More recently, we installed a system for a customer actually in Asia, and they ran a 200-hour test on our batteries, which essentially performed non-stop, constant back-to-back cycling of the battery, full depth of discharge at rated power for 200 hours, which equates to about 8 odd days or so. The battery during this test ran 26, I think it was, cycles back-to-back with 0 rest period and 0 change in the power that you're getting out of that system. You can see with the graph we have on the right, that top green line is the state of charge of the battery. Again, you could just see it up and down, no rest period at the top or the bottom. And the bottom graph there is the power of the battery, just continuously 50 kilowatts for the module, in and out for that sort of 8.5 days straight. And this was a really powerful demonstration of what we knew as our product could do, but seeing a customer out of our hands, not a test that we were running in our lab or even in our factory, seeing a customer take our battery, run it through this duty cycle, and have it come out the other side as successfully as it did was a really strong kind of message of validation for us. We took that one step a little bit further. Again, all of this data, we're gathering thousands of data points a second that we feed up to a secure cloud that we can access and analyze really in great detail. We added that third level of electrolyte temperature. So the same 2 graphs on the top, state of charge and power, but then we just add in electrolyte temperature on the bottom there. And as you can see, it bounces between about 39 and 46 degrees Celsius. The temperature on site here was much warmer than the UK. The average over a day ambient temperature was over 30 degrees. So here you can see the system stabilizing between that 40 and 45-ish degree. That similar sawtooth profile we see, cooling down as the battery charges, heating up as the battery discharges. But over those 8 days, you can see we're not reaching runaway. We're not reaching any sort of hard limit where we're hitting a stop point. The battery's operating non-stop, and that temperature is remaining stable in quite a warm, humid environment. And that, again, was just fantastic validation of an external customer running the battery through this kind of duty cycle that we love to talk about in our commercial discussions. So really there, we've just talked about how we've gone about proving our battery's performance to the outside world from customers and also third-party verification companies like DNV. We're proving the specification of the batteries is equal or greater than what we're putting out on our information and data sheets, proving the batteries can coordinate amongst each other to develop and deliver not just single battery performance, but scaled up to multi-megawatt level systems. Those batteries are incredibly flexible, able to cover any sort of dispatch condition the customer might want, and future-proofing that site to any changes in the market that might exist. And they're also very durable, and they're on track to deliver that expected durability and lifetime that we're warranting and we're selling to these customers. And these products are continuing to deliver these every single day all around the world on almost every continent. And that's an incredibly powerful message that we get to give out. And these capabilities are only going to be enhanced by our next generation product, which is, as you saw on the screen, codenamed Mistral, that has increased performance, decreased costs, as well as bringing all of the learnings that we've got for that for the VS3 product into that same package. So thank you, John.